In this video, we'll address the inverse trigonometric functions. So you may recall from the past that functions that are one-to-one have an inverse. That is, we can solve for some f inverse that, in a sense, undoes whatever f has done. So we will define the inverse trigonometric functions for sine, cosine, and tangent. But first, we will look at the definition of inverse. So the definition of the inverse of a function: let f be a one-to-one function with domain A and range B, then its inverse function, f inverse, has domain B and range A and is defined by f inverse of y equals x if and only if f of x equals y for all y and b. Additionally, f inverse satisfies the cancellation properties. F inverse of f of x equals x for all x in A, and f of f inverse of x equals x for all x in B. Important to remember that f inverse is not the same thing as 1 over f of x. But hold on, because the trigonometric functions aren't one-to-one, right? For example, consider our sine, which goes like this, like this, like this. If we tried to do the horizontal line test, like that, it doesn't pass, which means that in this version of its definition, sine does not have an inverse. So what we can do, because inverse functions are very useful mathematically, we can restrict the domain of sine, cosine, and tangent. So if we draw another set of axes like this and have, that's our sine function. If we restrict the domain to here to here, which would be negative pi over 2 to pi over 2, then we can create an inverse. So similarly, consider cosine, which we know that cosine looks something like this. It's convenient for us to define the restricted domain for cosine so we can get an inverse as 0 to pi. And lastly, recall that tangent looks something like this. So if I draw any more than this one period of tangent, it won't be one-to-one. So we can restrict tangent from here to here. And of course, since pi over 2 and negative pi over 2 both are not included for tangent, then we have to exclude those in the new domains. So we're going to restrict the domains. Restrict 2. For sine theta, we are restricting the domain to negative pi over 2 to pi over 2, inclusive on both sides. For cosine of theta, we're going to restrict the domain to 0 to pi, inclusive on both sides. And for tangent theta, we can restrict the domain to negative pi over 2 to pi over 2. So now, with this information, we can define the inverse trigonometric functions. Inverse sine, inverse cosine, and inverse tan. The sine, cosine, and tangent functions on the restricted domains, negative pi over 2 to pi over 2 inclusive on both sides, 0 to pi inclusive on both sides, and negative pi over 2 to pi over 2 exclusive on both sides, respectively, are one-to-one and so have inverses with domains and ranges as follows. For the function sine inverse, we have domain negative 1 to 1 inclusive on both sides, with range, the domain of our restricted sine, negative pi over 2 to pi over 2 inclusive on both sides. We have cosine inverse with domain negative 1 to 1 inclusive on both sides, and range 0 to pi inclusive on both sides. Again, the domain of our restricted cosine is the range of our cosine inverse. And for tangent inverse, we have a domain of all real numbers with range of negative pi over 2 to pi over 2 exclusive on both sides. And then finally, the functions sine inverse, cosine inverse, and tangent inverse are sometimes called arc sine, arc cosine, and arc tangent, respectively. So So now let's look at a quick example so we can make sure that we understand what exactly is happening with the inverse trigonometric functions. So let's find the exact value of sine inverse root 3 over 2. So I think in these cases it's always really helpful to remind ourselves of the domain and range of our inverse trigonometric functions. So for sine inverse, the domain was -1 to 1, and the range was -pi over 2 to pi over 2. So this kind of means that we're handing it some real number between -1 and 1, and we're getting out an angle. That is, we're getting out an angle between these angles. Right, I could go -pi over 2 in the clockwise direction. I could go pi over 2 in the counterclockwise direction. So we're trying to find the angle that has the value, this positive square root of 3 over 2. Now that certainly doesn't happen in quadrant 4, right? Because all of those would be negative y values. That means that we're going to be looking for an angle in the first quadrant, quadrant 1, that gives us out a square root of 3 over 2. And we know this pretty well at this point. We know that the sine of pi over 3, or equivalently the sine of 60 degrees, gives us the square root of 3 over 2. So sine inverse of the square root of 3 over 2 is pi over 3.